In this video, we're going to be building on the Pythagorean theorem. We've done a couple of problems in class about Pythagorean theorem, and in every instance, we've been giving a decimal answer. And this video is going to introduce how to give no decimal answers anymore. All right? So we're going to be introducing this new topic of radicals. So a radical is a number that has the square root symbol in it. The square root symbol, which you've always thought of as it, is actually called a radical sign. Now you will hear me refer to it as both the square root sign and the radical sign, but in terms of other classes as you continue to go on, any number that has a square root symbol is called a radical number. So you'll see that here I have solved a problem for Pythagorean theorem down to m equals the square root of 18. From now on, we will be giving no decimal answers unless it's an application problem, like a word problem. So what we're going to be doing is simplifying radicals. So this is all about simplifying a radical answer, like the square root of 18. You always have to give your answer in the simplest terms. That is not a new concept. Think back to when you were in middle school, all right? You were doing a lot with fractions, correct? Fractions, you always had to simplify to give the correct answer. So let's look at that a little bit more. When you were doing fractions, you had to simplify 3/6 down to 1/2. You had to simplify 5 over 25 down to 1/5. What I'm going to be showing you in this video is how to simplify the square root of 18. And what we're doing is we are simplifying by factoring out any perfect squares. Okay, so perfect squares are your numbers that when you take the square root give you a perfect whole number. Your examples are the square root of 4, which is 2 times 2, the square root of 9, which is 3 times 3, the square root of 16, which is 4 times 4, and so on and so forth. So we're going to be trying to factor out these perfect squares out of any radical answer. So I'm going to show you two methods. The first one is going to kind of show you how we factor out those perfect squares. The second one is going to be the one that you're going to use more than anything. So, square root of 18. Think of two numbers that multiply to give you 18, and one of them has to be a perfect square, like 4, 9, 16, or something else. So can we multiply 4 times anything to give us 18? No, we can't. It'd have to be a decimal. We need only whole numbers. Can we multiply 9 times anything to give us 18? Yes, we can. So let's think of this like a factor tree. We're going to break the square root of 18 down into the square root of 9 times the square root of 2. If we multiply radicals, then we only multiply what's underneath them. So the square root of 9 times the square root of 2 would be 18. The square root of 3 times the square root of 4 would be the square root of 12. All right, just a little side note there. We can multiply numbers underneath the square root symbol or the radical symbol. Well, back to here. What is the square root of 9? You should immediately know that the square root of 9 is, in fact, 3. Can we take the square root of 2? No. So we cannot simplify the square root of 2. But we have factored out that perfect square into 3 square root 2. That is one of the ways that we simplify radicals. But you may have a hard time thinking about those perfect squares. What is a number that multiplies times 4? What's a number that multiplies times 16? So we use a method that I like to call the breaking out of jail method. Instead of using the perfect square numbers, we're going to think about these pairs, all right? Think back to when you were in elementary school. Do you remember ever creating a factor tree? When we create a factor tree, we are breaking a number down into all of the prime numbers that multiply to give you that number. All right, so I'm going to break down 18 into a factor tree. Now, because this is the breaking out of jail method, jail is the radical symbol. Right now, poor little 18 is in jail. He wants to break out, or his friends that make him up want to break out. So let's break down 18 into a factor tree. Two numbers that multiply to give me 18, the first thing that comes to my head is 6 times 3. Can either of those break down further? The 6 can. So I'm going to break down the 6 into 2 times 3, and I'm going to bring the other 3 down. So these numbers all want to break out of jail. And if you think about news stories, people always break out of jail in pairs. They always got to have a buddy. So we're going to have the same thing happen here. Pairs can break out of jail. But there's one problem. When a pair breaks out of jail, only one person makes it. And if you don't have a partner, you're stuck in jail. So with this, 2, poor little 2, gets stuck in jail. 3s, a pair of them break out, but only one of them makes it. So 3 gets out of jail. And that is the simplified radical of the square root of 18. See how we got the same answer? But most people do better on the breaking out of jail method because it requires less work on thinking of numbers that multiply together. So let's just do a couple real quick as practice. Square root of 25. All right, you already know that that's 5, but let me show you how the factor tree works. 25, only two numbers that multiply to give me 25 are 5 times 5. I can't go any further. Those are both prime numbers. I got a pair that breaks out of jail, so the answer is 5. 24, two numbers that multiply to give me 24. Let's go with 6 and 4. All right, two numbers that multiply to give me 6 are 3 and 2. Two numbers that multiply to give me 4 are 2 and 2. Now, who gets to break out and who stays in? I got a pair of 2s. One of those 2s is going to break out. Neither the 3 nor the 2 over here have a partner, so neither one of them get to break out. They multiply back together and stay in. So 2 square root 6. So if you stay in jail, you multiply. Now let's do the square root of 32. Two numbers that multiply to give me 32. The first thing that comes to my head is 8 times 4. Let's break that down into 4 times 2 and 2 times 2. And then break 4 into 2 times 2 and bring everybody else down. All right, who's breaking out? Who's staying in? I got a pair of 2s. I got another pair of 2s. And I got a little lonely guy. Little lonely guy stays in jail. When you break out of jail, you multiply. Think about that. When you break out of jail, you multiply. So we're going to have 1 2 breaking out, then we're going to have another 2 breaking out, and they are going to multiply. 2 times 2 is 4, so we end up with 4 square root 2. One last one, 21. 21 breaks down into 7 times 3. I can't go any further than 7 times 3. Those are both prime numbers. So nobody breaks out of jail. That means that those multiply back together. Square root of 21 cannot be simplified. So I hope that this made sense. We'll go over it in class as well, and we will continue to use this throughout the unit.